But I want to find the area between the two graphs without knowing what the graphs actually look like. Well, what looks like from the graph something important for me to know here? Not the apex. Good try. Where they intersect. I need to know where they intersect. Where they intersect is going to constitute my lower bound and my upper bound. Now, how can I figure out where they intersect if I don't have the graph to look at? I've got the equations, I don't have the graph. How can I figure out where the graphs intersect?
Well, you can already look because they have the same.
What now?
They have the same y-intercept, so they intersect.
But you're looking at the graph to see that, aren't you?
No, it's in the equation. They're at the end. It's both +3.
Okay, all right. But see, yeah, ax plus b, yeah. All right, I see what you're saying now. That works in that case, but works well in that case, actually. Let's look at it a different way. Because they're not always going to have that same y-intercept. If we set the two equations equal to each other, and we solve for x, we would also have where they intersect. So, I'm going to pull this equation over there. So 0 equals, it's going to be 2x squared minus 6x, and then that goes away, right? The 3's cancel out? Okay. So set this equal to 0. I'm going to factor a 2x out. So I've got x minus 3. So I get an x equals 0 and x equals 3. Those are my two intersection points. So you are right. The 3 was the y value where they intersected, so they shared the same y-intercept. That doesn't happen very often. It did in this case. But this does work every time. All right. Now, the next thing here is, again, I'm not looking at the graph. But I said, to get the area, we need the top equation, take away the bottom equation. So based on that, how could we figure out which one to subtract from the other if we don't have the graphs to look at? There are a couple of correct answers here.
Positive minus negative.
It's actually, but look which one's on top there. If you look at the graph, now go back and look at the graph, which one's on top though? The negative one's on top of the, so that's not going to work. Good try. There are a couple of different ways to do it. One way is to pick an x value that's in between the two. Let's pick one. Let's see what we get here when we plug in 1. So negative 1 squared would be negative 1, right? Negative 1 plus 2 is
2.
negative 1 plus 2 is 1. 1 plus 3 is 4. 1 minus 4 is negative 3 plus 3 is 0. So my y value at 1 is greater in this equation than it is at this equation. So that's one way I can say, oh no, y sub 2 needs to be above y sub 1. So I'm going to have from 0 to 3, of y sub 2 minus y sub 1.
Say that again.
Say that again.
Say that again.
When I plugged in 1 into this equation here, I got 4. When I plugged in 1 to this equation here, I got 0. So since 4 is greater than 0, yeah, I know that this one is on top of this one. Yes?
You said there are different ways of doing it.
Yeah.
That's
You want to know another way?
Yes.
That's one way. All right. The other way is this. These two parabolas intersect each other, right? Now, just based on what you know about parabolas, this one opens how? This one opens up. If I have two parabolas that intersect in two different places, one of them opens up and one of them opens down, the only way that intersection can happen is if the one that opens down is on top of the one that opens up. So you don't necessarily have to look at the graph to know that. Some of it's just understanding what the graphs look like without. But if you don't understand what the graph is, if you look at it and you just don't see what's happening, you can always go to picking a point in that region. But the quickest way is to understand that the parabola that opens downward would be on top of the parabola that opens upward, if they do intersect. All right? So, let's solve out and find this area. I've got 0 to 3 of negative x squared plus 2x plus 3 minus x squared minus 4x plus 3 dx. Okay, now, I'm going to combine like terms because I would rather combine like terms than do the antiderivative of each one of these separately. So, negative x squared and negative x squared is negative 2x squared, right? 2x minus negative 4x is,
6x.
are y'all good?
6x, because you have negative and
Yeah.
so that changes the
Yeah. Are we good here? All right. So, 3 minus 3? 0. So this is my function that I want to integrate. So, what is the antiderivative of negative 2x squared?
Negative 2x to the third equals to 3.
Mm-hmm. And then it's plus 6x squared over 2, which would be
3x.
3x squared. And we're going from 0 to 3. Okay. 3 cubed is
21.
27.
7, yeah.
And then 27 times negative 2, negative 54. So I have negative 54 over 3. Oh, I could have easily, this is dumb of me. I should have just let that 3 cancel out with one of those and had 3 squared there. Oh well. Still get the right answer. And 3 times 9 is 27 still, right? Okay, so negative 54 over 3 would simplify to become what? And negative 18 plus 27 is? 9. So my area between those two curves would be 9. How was that? Okay. Now, let's take this one for example. Now again, if you know what these graphs look like, then you don't really have to do all those steps in there, but if you don't know what they look like, then you would want to do them. But let's look at f of x equals the square root of x, and f of x equals x squared. Okay, the area between those two graphs. Well, where are they equal to each other? 0 and 1? Okay, so you can say x squared minus x to the 1/2 equals 0, or let's just say x squared equals x to the 1/2. Square both sides. X to the 4th equals x. X to the 4th minus x equals 0. X times x cubed minus 1 equals 0. So x equals 0 and x cubed equals 1. What's the cube root of 1? 1. So all right. Which one's on top? Between 0 and 1. Square root of x is on top. Think about what the graphs look like if you don't remember. Square root of x looks like this. X squared looks like this. So the square root of x is on top of x squared between 0 and 1. And if you don't know that, what's the square root of 1/4?
1/8 or 1/16.
1/2. And what's 1/4 squared? 1/16. You were ahead of the game. All right, so 1/2 is definitely greater than 1/16. So square root of x is on top. So we're going from 0 to 1 of x to the 1/2 minus x squared. Are y'all with me? All right. What is the antiderivative of x to the 1/2? 2/3 x to the 3/2, good. And then it's minus x cubed over 3, good. And we're going from 0 to 1. So this is going to be 2/3 minus 1/3 minus 0. It's always nice when 0 is one of the intersection points. So 2/3 minus 1/3 is 1/3. So my area between those two graphs is 1/3. So if I constructed this little square right here, that would be 1/3 of the area of that square. Just think about it again, all the kids walking around the school that don't know that fact right there. And now y'all do. Y'all are the only students in the school who know that.
No what?
Okay, some of y'all know it. That the area between the square root of x and x squared is 1/3 of a square. All right, anyway, I think that's a good stopping point. So for homework, I want you to, we did question 3 together. I want y'all to do, the rest of 1 through 6 that we did not do.